Welcome to another Fireside Chat. My name is Christopher Penn. Today we have Despina Christou. I hope I pronounced that correctly.
Perfect.
Awesome. That's the win for today. From who's the chief AI scientist at GoCharlie. So Despina, let's start. Who are you? What's your background? How did you get into becoming the chief AI scientist of a tech startup?
Oh, long story. So, hi everyone. Very nice to see you all. I'm Despina. I work at GoCharlie. Started the company almost 1 year ago, and I'm the chief AI scientist here. Um, so guess what? My background is in computer science. I hold a master's in AI from the University of Edinburgh. I'm also a PhD candidate in natural language processing at the Aristotle University of Thessaloniki, which is where I'm currently based and talking to you from. And I have worked both in academia and in industry. So I've seen data science and machine learning from all the aspects. I was working as a machine learning engineer for over 7 years and had the chance to work with plenty of amazing people, but also had the chance to work with various types of data, mostly with text, images, and financial time series, and which is how I got into a bit of data science, but mainly into machine learning. And now I'm focusing mostly on text data, which is also the focus of GoCharlie, mostly via deep learning models, which is the state of the art the last like 4 or 5 years now. But like, especially for any young people wondering how someone might end up in this job, my truth is that I didn't know I was going to end up this way. Everything came naturally and step by step. When I was like an undergraduate, there was barely any data analytics, machine learning, or AI courses in my university back in 2010-11. And so I didn't have like how to see all this new world around me. And I was fortunate enough to choose a nice topic for my bachelor thesis, which was like movie recommendations by comparing traditional machine learning approaches and the recent autoencoder and neural-based methods. And I fell in love with the field. And the main reasons was because it was the very first time in my life that I understood why we learn math and how and where we should use them. So truly a new world. We've been learning maths all these years, but like usually the children think, why I'm learning this? And for me, this bachelor thesis was the why. And the second reason was I fell in love with this area because I learned methods which were almost domain agnostic, and that was like a superpower that served me well in the long run, because like you don't always know at the outset what area you want to focus on, and usually that's the case for any young person, and for sure that was the case for me back then. And this is how it all started.
Awesome. Now, are you more of an R person or a Python person, or neither?
Python. I started with C++, then I moved to Java, but the last years I work with PyTorch, which is closer to Python. So I would say Python.
That's curious because I used to work with C++ as well, and I find that R's syntax is closer to C than Python is. What made Python's easier for you?
It's the syntax. It's basically the syntax. Yes, it's very very easy to work on. Most of the libraries out there nowadays are in Python, and the deep learning frameworks I started to use and work on was PyTorch, which is closer and more compatible to Python. Of course,
Gotcha.
the more optimization with PyTorch, again, they are in C. For speed purposes. So it depends on the application. Most of my time I work with Python and PyTorch.
Okay. So what does a chief AI scientist do for GoCharlie? What is obviously within the bounds of your NDA, but what does your day-to-day look like for being a chief AI scientist?
So In general, at GoCharlie, I developed the core machine learning models and processes behind GoCharlie, along with my very talented co-founder and CEO of the company, Costas, which he's also a computer scientist. So the task is to keep us one step ahead of any competition on a technical level, and of course, to make sure that this is reflected in our product. And an example of my day-to-day tasks include study the state-of-the-art research coming up every day, especially the last few months. Every other day, it's new research out there, and see how it affects the current technology that we have, how and if we can improve it, and how we can quickly incorporate these new optimizations or new technologies to the current models or procedures. So I develop new models, I develop new prototypes, mostly based on the roadmap or users' feedback and wishes. And once we are comfortable with the outputs as a team, I move to deploying them on the development server, which is not as easy as it sounds like most of the times. And in that task, monitoring plays a crucial role in the effort to try to identify potential risks ahead of time.
When it comes to the language models that you're using, what's your opinion of closed models like GPT-3 from OpenAI, which is available via API, versus open models like the GPT Neo X models from Elithra AI? Do you have a preference? Do you have a set of feelings towards these different, really large scale models?
So I will speak as a researcher and not as a co-founder here. I can say different things. It's nice that there are providers like OpenAI that offers GPT-3 for most of the people out there. And of course, this is an amazing technology, but at the same time, working with either developing AI models from scratch or use open source ones gives you a ton of opportunity to tune the model, optimize that, change that, especially if you know how to do that. And we do have expertise in GoCharlie in this. You can achieve way better results. You can customize that. You can do that optimal for the specific domain and task you work on, which is something different than having a general scope model. So OpenAI is amazing, but it's a general scope model. Pre-trained models are also perfect because they provide you with a very first start without having to spend like millions of dollars to train them. So you can either fine-tune that, or you can even customize that, the exact code, go in the code and change that, optimize that. And it depends to your granularity of knowing the neural networks. What's your resources? What is your time? What is your budget? So it's amazing that we have all of those because each company or its own individual or researcher can choose.
How do you see transformer models, or how do you see the research around transformers developing to deal with the memory issue? So, for example, if you were to go to any of these big transformer based language models and say, write a story about someone having a coffee date, after just a relatively short period of time, the current models out of the box with no tuning just forget like what they've written, and so they can start to repeat themselves, or for example they may create a named character and then forget that character exists like 5 paragraphs later. How do you see researchers trying to deal with the memory issue so that transformers can create longer form text that's still coherent?
So where you're trying to go here is model and data drift, or or how we can embed a reasoning in longer form of text.
The latter. The latter. How would you, for example, one of the things that's blocking transformers from being able to write an entire novel is that they can't they don't have a structure to follow.
Yeah, so this is very interesting, and we do see that even though these models are truly transformers and they can do almost anything, in truth, they cannot. There are some obstacles. And this is why there's new research coming on, like how we can combine cognitive science with neural networks and how we can embed logic combined with huge models so we can write longer form of text like novels, books, in steps. So deep learning is amazing, but when it comes to longer form of text, the truth is that if you want to achieve great results, you need to embed a logic behind that and do that in steps. I've tried and I've spent like months and months trying to optimize that in a single model. I couldn't achieve that. And so my honest opinion is that best results would be from a combination of a rule-based system and neural networks. And when I say rule-based systems, it might be a cognitive reasoning behind that process. That's what Jan LeCun from Meta discussed on KDD conference almost 1 month ago. This research is in its very early stages, but it's nice because it's we have covered the like the computing power allowed us to have these huge models that can automate plenty of tasks at the same time, and now is the time to see how we can go one step further.
Do you see it being a function of having multiple models collaborating, where perhaps one model creates a series of prompts and then a second model generates the text for each of the prompts, but in short bursts, so that you have the list of prompts is coherent enough because it's relatively short, and then each and then the second model just writes just enough text before it starts to drift and then tackles each prompt sequentially, and then kind of the same way that, for example,
one way. Yes.
Okay.
That could be one way.
Okay.
But again, there's a reasoning behind how you link all these prompts in a proper sequence that, for example, when it comes to novels, it will actually create a story. It will evolve the story. So the relation and linking of these main points of the story, you need a reasoning behind that.
Gotcha. Okay. What are some of the more interesting AI challenges you're working on right now? Obviously, we've talked something about transformers to some degree, but what are some of the other interesting challenges you're working on right now?
Plenty. I think every day is a new challenge, and most challenges in my days include AI systems integration and optimization in the cloud. And it's very different to make a proof of concept and create a prototype like in a Jupyter notebook, and then take that and get it into a proper code, and then also take this code into production. You need to optimize the libraries for memory issues, and you might have several other things. And another challenge in a good way is that every other week there's more optimizations coming out hardware-wise, which of course is great because it allows us to offer a product at higher speeds, spending less amount of money in our infrastructure. But trying to move fast and integrating or upgrading existing solutions to new hardware with new technologies like deep speed or other similar optimization software, it can be challenging. But that's the interesting part of the day as well. When you achieve it and you can offer something to your clients that can work faster and cheaper for us, and it's amazing. The feeling is good.
For folks who are tuning in who don't necessarily know what a transformer is, how do you explain transformers to people who are non-technical?
Very interesting question. So it's good to think as the series of Transformers, that they can do almost anything. And in general, neural networks and especially transformers, they can start with any task, and they are learning themselves how to do a task. When it comes to text generation, the task is given a content, find the probabilities of what is the most probable next words. But how all this learning is performed through multiple layers and through multiple optimization steps. Someone can think of that like our experience in life. We are born, we know nothing, and this nothing part is the weights, what we call weights in the models. And then we start walking and we have experience. And for example, I'm born in Thessaloniki in Greece, and then I travel to the States. I have different experience. I'm working as a machine learning engineer. I'm a co-founder. I also do the business part. So the more data, the more information, the more different tasks. For example, the more countries you travel, the more people you meet, the more cultures you experience. Your learning is optimized, and you can better generalize anything. So that's the idea behind transformers. It's a huge neural network that can perform learning given terabyte of data, and they can automatically learn information out of all of these. The typical task is how to generate the probabilities of the next words.
Are transformers limited to text?
The typical, I think now yes, but I think you can also tune them to work with images.
Okay. Well, I was asking because I saw some research not too long ago where someone had taken a natural language processing model and applied it to RNA sequences to say, okay, well, RNA occurs in patterns as well. So could we predict the next mutation of a given virus?
Mm-hmm. Yes, so neural networks work with vectors. So anything that we can encode in vectors, even that is an audio, if this is an image, this is an RNA sequence, these can be passed as information to this massive neural network and get an output. So the answer is, if you can encode something in mathematical vectors, this is all the information that this architecture, which is called transformer, and basically the neural network, can handle to do something. So the answer would be yes.
Okay. For when you see press releases come out about these different models, GPT-2, GPT-3, GPT Neo X, you hear, this one had 39 billion parameters. This is 175 billion parameters and stuff. Are more parameters better? I mean, is that just kind of how we measure the effectiveness of these models, or is that just marketing speak? Is there something else we should be paying attention to?
Both. Both. So for a general scope application, the more parameters tend to better understand data, no matter your pre-processing. And the more data you give, for example, it can better understand the context behind words, the context behind images, no matter if these data are coming from different tasks, from different industries. So bigger models with billions of parameters generally tend to perform better, but for general scope applications like the GPT-3, my concern here is, to train such models, you need months of training and millions of money, and yet they are the best for general scope applications. they cannot perform that well in industry-specific applications. And the truth is that if you want to have the best model for marketing or for biomedical or for any more niche area, a smaller model with customizations targeted for these domain peculiarities, I would say, usually performs better. And the other part is that smaller models are easier to handle, to customize, to store, to deploy. You get faster inferences. So it depends to the application. It's not,
Okay.
for me, it's not one problem solves, not one model solves everything. For niche areas, you need niche models.
How much information do you need to successfully fine tune one of these models? Is it just a little bit of text? Do you need thousands of blog posts? How much is necessary to effectively fine tune?
It depends to the application, I would say, and to the pre-trained model we start from. If the pre-trained model has already been trained on blogs and knows how to create blogs, for example, that we would like to teach that how to create blogs for a specific area, let's say for Coca-Cola or for any specific brand, then only few samples, and when I say few samples, it might be even like few thousands, it can be enough. But if you start with a pre-trained model that hasn't seen your specific task in its training data, you would need more. It depends on your resource. The more, the better, but few hundred thousands to few millions, usually that's the case.
Gotcha. So if you're trying to tune a model to sound like you specifically, and you only have like 100 blog posts you've ever written total, it sounds like it might be you might not be able to get a model to do that.
Again, it depends where you start from, your pre-trained model, and you can do plenty of more things there.
Okay.
And again, it depends on the model. For example, the new diffusion models, if you see Dream Booth, they can fine-tune these models to specific type images. With just few images, they can replicate images like you, for example, and like with just 20 or 100 images. So it depends on the architecture. Diffusion models work a bit different, transformers a bit different, and again, it depends what these models have seen in their training data.
Yeah, that's been my experience. That was Stable Diffusion. I found like 30 images was enough to push the model in one direction.
Yeah. But at the same time, you should think that for these only images, it takes about 1 hour for fine-tuning, while for any transformer-based model, in 1 hour, you would fine-tune like thousands of... they are different architectures.
Yeah. Can you talk about some of the work you're doing with data that you work with today around the identification and mitigation of bias in the models?
Yeah. So data collection, cleaning, and processing and storing is an ongoing effort at GoCharlie. We have developed innovative pipelines that process data from different formats fast in a standardized way while mitigating bias at the same time. And we do that mainly in the cleaning process, where we clean data from unsafe data, bias, sexual harassment, or any other non-safe types of content. And the other thing is that we make sure that the data we keep and feed to the models are balanced across different domains and tasks. For example, we don't want the most open source data for social media out there is about Twitter. But we need to have balanced data from several social media platforms and not only Twitter. So we balance this data. And when it comes to cleaning the data from unsafe content, we use both open source content filters or moderators, how they are called. Also, we use the one from OpenAI, and we're also developing our own one to allow us have greater flexibility and customization of the model.
How do you deal with the fact that the optimization targets are generally not necessarily things you'd want to optimize for? For example, let's say you have a corpus of data from social media and you get rid of the obvious stuff, hate speech and things. You get rid of that, and you're still looking at engagement. The content that gets the most engagement still might not be a good thing. Like, it may be full of people who are really angry, and so you optimize a model based on highest engagement, and you basically are training a model to generate text that will make people really angry. How do you tackle that, and how do you think about that from an ethical perspective?
Yeah, so even data that come from like angry comments or happy comments, this is also something that we need to balance our data upon. So you do have usually, like, for example, for Facebook post, we can see this information. We do have like, open your timeline on Facebook, you can see that it's posted. You can see how many happy faces, sad faces they are seeing with the emojis of its post. So that's an information you have. And if you have a good pre-processing step to clean the data before feeding them to the model, you can change this bias. Of course, there's the ethical part. Do you keep the post? Do you have an equal balanced data across all emojis? Is angry post of the same weight as the happy ones? These are difficult decisions to make. For start, if it comes just to the emojis, because emojis are used out there, I would say a balanced data is where you start. But then what you need to do is to apply content filters for potential outputted content that is biased, and also provide the human the opportunity to rate this content. Do they like that or not? So we do use this information to constantly improving our models, information coming directly from the users. So these feedback loops also take into account output as coming from content filters, but also the actual rate of our outputs from users. Like, we use thumbs up, thumbs down, for example, but you can see that everywhere. The rating systems that we see online, they are used for that, to incrementally, or they should be used for that, to take this information and incrementally improve the models to create something closer to what users would use most and like.
Okay, so essentially the user ratings function as an additional set of model weights?
At high level, yes, it can. Usually we add this as a feedback loop, where every few other times, and depends to the problem, you improve your model based on this feedback. So create less hate speech or create less sad related posts. And something that is also very important for us we provide content scoring for our own content.
Mhm.
That's an extra layer of making sure that we provide users the ability to see how their content will perform and how it will perform based on several aspects. And one of these aspects is sentiment, for example, is objectivity, is formality, which are important for common speech and social media out there.
Do you connect to people's like social media accounts or search console accounts so that you get platform metrics? Like, you connect to my Twitter account and then it looks at the tweets that it's generated and say, okay, these are the ones that the model generated and they got 4 engagements, and then here's some other ones that got 12 engagements. And can you then tune that user's model based on the objective data coming back from the performance of their content?
That would be awesome. We don't do that yet, but we are open to collaborations for case studies on the exact paradigm you said.
Okay. How quickly do these models, like transformers and diffusers, how quickly do they drift? And are companies that are using these in production, how carefully do you feel like as an industry people are keeping an eye on model drift?
So, very interesting question, and we've been discussing that with our team. My main concern here is that most of these models, it's few models that have been used from most of the companies out there. So, for example, if we take into account GPT-3 that is used from almost one of us, the question is how they are concerned with model drift, because most of the companies that work with them, actually they can do nothing. They're just trying for their providers to handle potential drifts. So my main concern is here. If you use models from providers, you can't do nothing. You just wait from there. So this is important to make sure and ask for feedback how they mitigate this bias or model drifts. For example, GPT-3, we do know that every 2 or 3 years they try to retrain their models with new data. But in my opinion, this is not enough. Having worked with a large amount of data in actual production ready language models, it's tricky when you work with data that might change over time, that embed, for example, seasonality, consumers' behavior change, or there's new trends in social media, or actually news with all these things we hear around in news corpora. Your models should adopt on these new trends, on these new behaviors now. And not every 2 or 3 other years. It's good that they do that, but in my opinion, this is not enough. And this is why I highly suggest all companies working with AI to have internal AI teams that can improve and create these models themselves, so as they can improve these models like every few other weeks, if not lively, and not every few other years. This is the way to provide your users the best models that can actually adapt to the everyday news out there.
Mm-hmm.
And monitoring is important. So the typical way to do that is to monitor your model's input distribution. And if what your users input changes, that means that something in the world out there has changed. You need to go there and do something and improve yourselves to the new needs of your users, at least, if not the new things like globally.
Do you see diffusers being able to do short form video, basically taking a look at like what's trending on TikTok right now and be able to use that as a training data set to create essentially, machine generated TikTok videos, given their how short they are?
I think the answer is yes. There are some research groups that have started some attempts, not that great yet, but if they achieve that in just like few weeks after diffusion is up, of course, I think we will see amazing outputs in few months, I would say. So stay tuned.
Okay. And how should people be thinking about ethics around artificial intelligence? We know that these models are very, very good. We know, for example, deep fakes are now extremely good. In fact, some of the deep fakes that people can do on their home computers are better than what Hollywood can do in some of its movies, which is kind of funny. But we don't see a whole lot of conversation happening in the broad sort of societal discussion about the ethics around AI.
My point here is discussions around AI and its ethics is very different in the States and in Europe. So definitely the very first start is to check the discussion around the globe about ethics in AI and not just in a specific country or continent.
Talk more about that. What are the differences?
At first, there's like in Europe, we have GDPR. I'm not like, I won't judge anything. I'll just like discuss what I know of that. It's important, any computing system that we use to provide users information, like ads, to have the acceptance of the user to do that. In Europe, there's GDPR. In the States, we don't have that yet. About AI ethics, one of the hugest research directions the last 2-3 years in Europe and in the States is explainable AI. So if we want to use AI to make decisions for political purposes or for biomedical purposes, we need to have models that can explain how they got into this decision. And for example, the European Parliament decided that they would use AI to take and drive some decisions, but only AI models that use explainable AI. So explainability is a huge topic, and there's a huge research community around that, but only the last 2-3 years. So it's an emerging research topic. That means that we have more to see the upcoming years. And then it's the legal part. How you define ethics. Most of the open source projects out there, like the diffusion models, the Bloom language model from Hugging Face, falls under the Big Science license, which is the license for ethical AI downstream tasks. So there's been some work there. Of course, there's need more to be done, but we have just started. I think we operate pretty fast. We have content moderators. We have GDPR. Explainability in AI is an important thing. If you know as a doctor or as a government how the AI model got into recommend you that decision, and you can know the actual decision path behind that, I think that's okay. And when it comes to like people, it takes some time to familiarize ourselves with these new tools, because for me AI is just a tool, is nothing more. We shouldn't be afraid of it. It's an amazing tool.
It is very powerful. Like any tool, it's who's using it that is determines the outcomes.
Exactly, exactly.
Fine. Just to wrap up, what advice would you give aspiring data scientists and AI engineers, particularly women, and what would you warn them about in the field?
Um, my only advice to anyone, no matter their their gender, when it comes to data, is to give time to understand the data. And this is something that goes for our lives in general. We need to give some time to understand what's going on around us. We as humans sometimes we had to do that most. But when it comes to data science, give time to understand the data in simple terms, and then in even simpler ones, and structure this information in your mind and try to explain that like to your mothers, and then everything is clear. Like, because most problems are hard because we don't take time to understand them, and spending some extra time to understand the problem can move much faster the planning and the implementation of a solution. So it's okay sometimes to start slow, because it will help you move faster in the next steps. And about warnings, I would say keep in mind that this job combines several disciplines, like from math and statistics to machine learning, software engineer, ML ops. So it's a lot. So be prepared that you will likely have to get your hands dirty in all these fields. And when it comes to women, that you discussed that, um, I think if you want to do that, to do something, don't think that there's anything as as an obstacle. And of course, like not your gender. You might have some difficulties, but I think we're entering a different world, and it's good that we talk about inclusivity. But what I would like women out there to keep is, if you want something, just go and get that. It's normal. um,
Okay. And where can people find you online?
in most of the social media mediums, I prefer LinkedIn for professional discussions. I also have Facebook, Instagram. I also have TikTok, but I don't use it that much. I would say LinkedIn and Gmail is the easier way to find me.
Okay. And where can we find GoCharlie?
Oh, so GoCharlie. GoCharlie is GoCharlie.ai if you want to visit us like online. If you want to meet the team, we are spread across different states and countries and continents. So if you're in Pennsylvania, Denver, San Francisco, or Greece, just send us an email and we can meet you and have any conversation that you'd like to.
All right. Thank you very much, Despina. That is going to do it for this fireside chat.
Thank